All right, let's try this string thing. So what can we do if we want to sort the strings in such a way that they're alphabetical without regard to case? So it turns out that that strings have a useful method. They have a method that doesn't get us all the way there. Let's okay, in our example here, now I'm adding, notice I'm adding the same name, but it's now going to appear twice. And well, here, let's go to, yeah, here. Notice they're alphabetical order, but with the capital letters, and then the lowercase one comes last. And when I reverse that, the lowercase one, all the lowercase ones will come first, and then the uppercase in descending order. All right, but what if I want these to be together? Bless you. In other words, I want this to be with this one. Well, I'm going to have to do something else, another comparator, and so what I want is I want alphabetical, and let's see what we can do with that. So I'm going to write, I'll call it alphabetical comparator, and hopefully it'll work, and it will implements comparator with string. Again, if you leave that off, let me show you what happens if I leave that off. It's legal, not recommended, because look at what gets. Okay, I need to import it, and then the method that gets the compare method now has an argument of objects. And so now if I want to do anything with these objects, I need to turn them into the type of thing that I'm comparing with. That's the way life was before they introduced generics. And now, interestingly, now I get, okay, so I can implement all abstract methods, but now actually I get kind of an error on this one because it says I'm saying it's overriding a method, but it's not actually not overriding anything. So I don't want this at all. Okay, and this is, NetBeans has a nice thing about generating any abstract methods that have not been implemented, and then it does is throws new unsupported operation exception, to force you to put something there. So if I try to use this, and I'll get an unsupported operation exception. So that forces me to actually put something there. Now, it turns out that strings, now when you see, the book is a little guilty of this as well, in my opinion. When you write a method that returns a value, the ideal thing is to just have one return statement and have it be at the end of the method. You can write multiple return statements. You can have a method that returns in the middle of the method. That's legal, but it's not desirable, especially in a long method. It's absolutely, it's an absolute no-no. For a small method like this, it's sometimes okay to have multiple return statements, but even at that, I'm not going to do that. The book is a little guilty of that. If you look at that, it's better, in my opinion, just better form to, in this case, I'm going to define a local variable, and I'm going to return that as what I do. And then now in between, I'm going to write the logic for the method. Now you see what it's complaining about, and actually based on if you remember absolutely everything we talked about, you should know what the problem is. Do you know what the problem is? It's complaining. Yeah. Exactly. I've defined a local variable, but I have not initialized it. All right. Well, let's initialize it. Now it turns out that strings have a second method called compare to ignore case. And what do you suppose that does? That says two strings can be considered equal if they have the same characters, but if I have a character in a certain place and one has an uppercase and one has a lowercase, then it's still going to return them as equal. Does that make sense? In other words, I have two strings. If they're the same except for case, then it's going to say they're the same. If not, then they're going to ignore the case and decide whether or not they're equal. Okay. So the problem is that doesn't quite do it for us. Let's let me. Let's test it out, and again, the way that you do this is you instantiate your collection, your tree set, and you pass it an instance of the comparator. See, under the hood, if you don't do this, actually what's under there is the tree set has an instance variable that is a comparator, and if that's null, then it uses the compare to method of a comparable, unless it's not comparable. And in fact, we saw what happens if you put a non-comparable element if you try to create a sorted set that has non-comparable things and you don't give it a comparator, then at some point you saw a class cast exception. That was because they at some point they make a cast of what the object is into a comparable interface, and if that fails, then you get this class cast exception. If your class has implemented comparable, then it will succeed. All right, so let's continue with our Marx Brothers. If you have if you haven't seen old Marx Brothers movies, which are almost a century old at this point, you're really missing out. Anyway, but your mileage may vary. Okay, so in this case, what I want, all right, so I'm putting a name in twice, once with uppercase and once with lowercase. Now, what do you want? If I want to say, okay, if this happens, I only want one of them, that's sort of okay. But in this case, I want both of those. I want both of those to be there. And the question is, will they? Can you predict whether they'll be there or not? Again, say the one aspect of science and computer science comes in programming, where if you act like a scientist, then what do scientists do? They create hypotheses and then perform an experiment and then either confirm or reject the hypothesis. The experiment either confirms it or is counter to it, in which case you have to revise the hypothesis. So the thing is that if I want to compare two strings and ignore the case, then both of those Chicos are going to come up 0. So what I expect is that I will only have one of them on my set. And in this case, it happens to be the first one. I think if I switch these, not entirely, then the first one gets in. So you see what happened is the first one got in, and then I tried to add the second one, and it went through and then discovered that, here's 1 equals, comes up 0, and so I can't put it in. And it said, nope. And then notice that this is not consistent with dot equals, because those two strings, dot equals will be false. So in this case, there's nothing, you can't do this and still be consistent with equals. All right, so that was a nice try, and it didn't work, because I want both of these to be there. All right, so what happened? Well, what happened was, and we can use what happened as a clue to how to fix it. What happened was I had two strings, and they were the same except for case, right? So this equals ignore case is going to come up 0. But for those, what if I have two strings that are the same except for case, except possibly for case? If they're exactly the same string, of course, I want to reject it. But if they're the same except for case, I want to accept it. And there's, well, if they come up the same except for case, then I want to just do a regular compare to. You see that? In other words, if I have two strings, so the first cut was I said, okay, I have this equals ignore case, which is a very convenient method. If I didn't have that, maybe at some point we'll dive under the hood a little bit. What I think is powerful about approaching it this way is that we're working at a fairly high level of abstraction. If you wanted to write all this from scratch, what you would need to do is unpack the string into their arrays of characters and then go through and compare the characters one at a time. Not rocket science. It's actually something that as now programmers, many of you in your third or fourth language, should be able to do quite easily. But I mean, it's something. Doing that is kind of the risk is that when you have to do something like that, it's just too easy to screw it up. And I'm speaking for myself here, so it's too easy for me to screw it up. Your mileage may vary. Okay, so now what I want and what I'm expecting is now to see both of these guys on it, and there it is. And now notice that even though I added the one with capital afterwards, remember before I fixed it, first it added the one that was all lowercase, and then when it tried to add the uppercase, it rejected it. Okay, so now the uppercase one was added last, but now it appears first. Is it kind of clear why that happens? Well, I mean, why did the uppercase one happen before the lowercase one? Yeah.
Because the if statement tells the default value for comparing two strings.
Yeah, in other words, because we're using the compare to is still lexicographic. So basically what we're saying is, first because the lexicographic puts the uppercase ones first, then that's what it did here. And if that's what I want, that's fine. If let's say, supposing if I didn't want that, if I wanted to have the lowercase ones first, I could simply minus that, and now the lowercase ones first. Again, it depends on what you want. Okay, so that's how we can use a comparable interface, implement a comparable interface to override what the default comparable interface does. In other words, we use an instance of comparator to change the rule, the default rule, which is in the compare to method of a comparable class. Now, what do we do if we have a class that doesn't implement comparable at all, and we have a way of ordering them? Again, what we need in order for this to work is there needs to be a strict ordering. In other words, if I have two of these things, I always need to be able to say this one is bigger than that one, or this one is smaller than that one. Okay, so let's go back to our old friend, the single card, okay, which does not implement the comparable interface. And now we have the source code. We could add that to that, but supposing we either didn't want to or we couldn't. Maybe this is part of a library that we're using and we don't have access to the source code. And maybe they've even declared this to be final, as with strings. Remember, strings are declared, the class string is final. I can't subclass it and do anything with it. I could have done that with single card, but But what if I want to sort cards now? And by what rule? Well, let's, again, one of the conventions is clubs, diamonds, hearts, spades, in that order, and then the value order, we'll make ace the one, So we already have methods that do all that, but what we don't have is we don't have a comparator that does that. So let's write one. So a single card comparator is going to implement comparator of single card. And we need to, again, by now you're hopefully getting good at deciphering the red squiggly of death, as it were. And even if you're not, can't find symbol. If you can't find symbol, try fixing imports. Either fix imports and then cannot find symbol. All right, why can't you find the symbol? Single, okay, because I mistyped it. Okay, so that it, before, when Java first came out, there weren't any IDEs. My IDE consisted of Notepad and the command prompt. That is not a very good IDE. But we liked it, and we walked uphill both ways. All right, so now, again, fix imports. There, we found single card. And so, for some reason, the book also likes what you can do if you want to, quote, import everything in a package. You can use this star thing. I discourage that. I don't recommend that. And the reason is that even if I have a whole bunch of things I'm, quote, importing, remember, importing doesn't import anything. That's why it's a terribly named keyword. All it does is it allows me to use the unqualified name here. Just as a, if I didn't want to do that, I could simply use the fully qualified name, and that always works. Sometimes that's necessary, and that's one of the reasons why it's useful to not import the star thing, is I could have two packages that have classes of exactly the same name, and then it starts to get confusing. If that's the case, then really the only way you can proceed is to either you can import one and then use the fully qualified name of the other. So you're never out of luck when that happens. But anyway, regardless, okay, we have that, and then oops, got that. As you can see, I have very bad fat fingers, so okay, so abstract does not override abstract method. Again, I can type those in, or I can simply say implement all abstract methods. And these are things that they've kind of done that I think are not such a good idea. But okay, so here's compare. Now, how do I want to compare them? Well, let's, again, I'll start in, again, for a short method like this, it is not a terrible sin to have multiple return statements, because you can look at it and have it be pretty clear. Nevertheless, I think it's just sort of a bad idea to even do that at all. So that's why I do it this way. Okay, so I set this up, and then again, there's a red squiggly because it's not been initialized. So let's initialize it. How do I want to sort these? Well, usually, depending on what game you're playing, let's say if we're playing bridge, do you know the game bridge? I think you have to be a certain age. I think millennials don't play that. They're more into what, Minecraft or anyway. But so bridge is a card game that your grandparents used to play. So and there you would, well, at the amateur level, you would sort your hand according to suits, because the suits are important. When you play a card and it's your turn to play a card, it has to be the same suit as what's been played, unless you run out. That's at the amateur level. At the professional level, they don't sort them. Why? Because if you're looking at someone and they take a card out of, if you know they're keeping them sorted and they take a card out of a particular place, you can make guesses about what's in their hand. Again, that's it. At the amateur level, you're too worried about following suit. Anyway, all right, so we're going to sort them according to suits. Now, here's the thing. Remember, a single card has a suit. And it turns out that all enums implement the comparable interface. So if I simply compare the first one's suit to the second one's suit, there are basically three options. Either it'll be a -1, a +1, or a 0. If it's a -1 or a +1, I want to basically, have it there. But if it's the same suit, then compare is going to be equal to 0, again, as we had before. And now what I can do is get the value minus the other. So what this will do is if this value is smaller than this one, it'll return a negative value. If this is greater, it'll return a positive value, which we'll put this one first. If they're equal, okay, now you say, well, what if they're equal? Well, if they're equal, that means that I have two cards that have the same suit and the same value. So whether they're the same object or not, I want to consider all Jack of Diamonds, whether they're the same object or not, to be the same card. Okay, does that kind of make sense? Sort of? All right, so let's test this out. We have time for one. All right. Now, again, the programmer virtue of laziness says let's use stuff. You know, if you're thinking bare metal, you think, well, okay, now I got to create. I want to create all my cards, but I already have a class that does that. Remember, I have card deck. Oops, CRAD deck card. Okay, and let's just make sure I've got everything okay. So, and it's created a whole deck of cards for me, and notice that they're all in the sorted order. So, let's shuffle them up. Remember shuffle or shuffle deck? Okay, so here they're all shuffled. Let's just. All right. So now they're going to come in. They're all in a different order, and now I want to put them back in order. Okay. So how can I do that? Well, I'll do this. Remember, we had all these methods that I had you do. Get my cards, and that will return an array of these cards, right? And okay, I need to fix the imports because now I got these. Now, remember, I have this arrays as list. And the arrays as list will only give me a list. It won't give me anything else. And it will give me an immutable list, so I can't add or subtract things for that. But I'm not really interested in that. What I'm interested in is now that they're shuffled, these will, because this is a list, they're going to come in the same order. So rather than tell you what, let's see what's in the list. Okay, so we see what's in the list is, in fact, they're shuffled, just to confirm that. All right, so now I want to resort them. And how can I do that? Well, I can do that by defining a sorted set. Okay, so I'm defining, and I need to fix some imports. Okay, so I'm defining a sorted set that's going to be a tree set, and I'm going to use the single card comparator, because as I showed you last time, if I don't do that, then I cannot put cards into a tree set because they don't implement comparable. But I think I've alluded to this method, but all collections have a method called add all that takes any other collection and just copies them all in. So, and I hope you're noticing that this is a fairly high level of abstraction that we're working with here. You know, there are things happening, like even the add all. Okay, if I didn't have that, I'd have to kind of loop through my list and add them one at a time. Add all does all that for me. I can just do it in one shot. And it's not that I'm saving keystrokes. It's that I'm making code that's clearer. In other words, if I, just even adding a few extra lines, it's like, okay, I have to take this little tangent and then loop through, write a loop and do stuff like that. Kind of what I had to do. The reason I did that here was because I wanted to print them on a separate line rather than having them all out there. Okay, so but what I'm looking for now, again, to print them on a separate line, I need to loop through again. Okay, so when I do that, print line, again, what I'm expecting, and again, I've done this from scratch. I wrote the comparator from scratch, and as you have noticed, that I occasionally make mistakes. It happens. Okay, so but again, being the scientist now, what I am predicting, my hypothesis, is now after the shuffle, I'm taking the same list of cards and I'm putting them into the tree set, and they should now be in the original order again. That's what I'm expecting. Okay, and we see that after the shuffle, okay, so I've marked it here, after the sorting, ace of clubs, deuce of clubs, diamonds, hearts, and spades. Okay, so what I've done is I've taken a class, the single card, that did not implement comparable, and said I want to sort them in this manner. I want to sort them by suit and then by value. Now, what if you wanted to sort them by value and then by suit? I'll leave that as an exercise for you to think about. Okay, so that's the utility of this, and the thing is that depending on what class you're working with, and we're going to kind of starting next week, we're going to look at some more complicated classes that have a bit more data, and you might want to sort them by some of the fields and not some of the others. The other one of the little gotchas, too, is that in both the case of strings, numbers, local dates, and single cards, they're all immutable. We actually didn't totally make that explicit, but remember, once I instantiate a single card, there's no mechanism for changing the suit or the value. I have no setter methods. And in fact, when you're writing a class that you want that for, if I have an instance variable and once I instantiate it, I don't want anybody to be able to change that value, then one, make it private, again, that's one of the prime, the things. Make it private and don't give a setter. And then typically in that case, you have to initialize it through the constructor. Okay, so that's useful. If I have a mutable object, and sometimes you want to do that, but if a mutable object is on a sorted set, and one of the fields that it's using to compare changes, then bad things can happen. So that's one of the don't do that type of thing.